Okay, when talking about motion, another thing we have to discuss is velocity. Right? You've probably used the word speed and velocity almost interchangeably, and to an extent there's nothing wrong with that, but there is a slight difference between the two. So if you remember our speed equation, we've got speed equals distance over time, and that was scalar. All right? Because everything that was in it, your distance and your time, were scalar components. All right? So in that case, speed, our direction does not matter. Velocity, on the other hand, is displacement divided by time. So our time is still scalar, but displacement is a vector. So because a vector determines your velocity, that makes velocity a vector. Okay? Which is why sometimes you'll see it written as a plain v, v equals delta x over t, or you may see it with the arrow because that's a helpful reminder that, oh hey, this is a vector. Okay? So your SI units for velocity are still meters per second, but you got to remember that direction. All right? Direction could be north, south, east, west. It could be up, down, left, right, or it could be positive and negative signs. Okay? So the biggest way to distinguish speed and velocity is when you are solving for an average speed or an average velocity from a long trip. Okay? Say something that takes multiple turns or takes hours or just, more than like a moment's time. All right? So to do this, to find average speed, you're going to take your total distance and divide by total time. For velocity, you have to figure out what your total displacement is and then divide by total time. All right? One thing to remember, time is scalar. So you always use your total time, everything all added together. All right? You don't subtract time because part of the trip was south. That south part is related to the displacement only. Right? So let's do some sample problems. Start with an easy one and then we'll get a little more complicated. So we have Mr. Runner running north for 4 seconds, and then he stops and turns and runs south for 6 seconds. And we have our distances. Again, just like when we were solving for distance and displacement, pictures help. So we have 30 meters north, and that takes 4 seconds. And then we go 40 meters south, and that takes 6 seconds. All right? So average speed, so speed equals total distance over total time. All right, so our total distance is going to be 30 plus 40, or 70, and our total time is going to be 10. All right, so 70 divided by 10 is 7 meters per second. So there's our speed. Now, for velocity, it's total displacement over total time. So our displacement is going to be a positive 30 plus a negative 40. Our time is still going to be 4 plus 6. So this is going to be negative 10 over 10, or negative 1 meters per second, or you could write that as 1 meter per second south. Okay? So another way to kind of think about this is your average speed is the time it takes to go that part from the start to the beginning, from the start to the end. Okay? Let's try one that's a little more complicated. So we have Mrs. Runner going 40 meters north in 25 seconds. So let's make that 40. And we have 25 seconds. And then she goes 30 meters south. Draw that a little longer. It does help if you try to draw your pictures to scale. 30 meters south in 18 seconds. And then we go back north. Another 10 meters. And that takes 10 seconds. And then lastly, we go south 20 meters in 16 seconds. Okay. So, average speed. speed equals our total distance divided by our total time. So our total distance is going to be 40 plus 30 plus 10 plus 20, because distances are what? Hopefully you are saying scalar, and that's why we don't need any negative signs. Our total time is also a scalar, so we also add up those numbers. All right, so 40 plus 30 plus 10 plus 20 is 100 over 25 plus 18 plus 10 plus 16 over 69. So you do 100 divided by 69, and you get 1.44 meters per second, or 1.45 if I round it correctly. All right, do I need a direction? Hopefully you're saying no, because speed is scalar. So our velocity is our total displacement over total time. So now our directions matter. So we're going to have 40 minus 30 plus 10 minus 20 over 25 plus 18 plus 10 plus 16. So our time never changes. Time is always scalar. Okay, so total time, you always add things up. So we're going to have 40 minus 30, which is 10 plus 10 is 20, minus 20 is 0. Okay, so 0 divided by anything is still 0. In this case, your velocity is 0 meters per second. You end where you began. Okay, so it's possible to get a 0 displacement and therefore a 0 velocity. So be sure to be able to calculate these and understand the differences between speed and velocity.